Graph the equations by creating a table of values and plotting the points. All right. For y equals 2x minus 6, let's do as it recommends and create a table of values. And I'm just going to choose a few values for x. Since the y is already isolated, it's generally easier to substitute for x and evaluate the right-hand side and find the values of y. So I'm just going to pick a few values here. How about negative 1, 0, 1, and 2? All right, so if x is negative 1, we would have 2 times negative 1 minus 6. Following the order of operations, that would give you negative 8. If x is 0, 2 times 0 minus 6 is negative 6. If x is 1, 2 times 1 minus 6 is negative 4. And if x is 2, 2 times 2 minus 6 is negative 2. So now we have some ordered pairs, right? We have negative 1, negative 8, 0, negative 6, 1, negative 4, and 2, negative 2. Plotting those points, negative 1, negative 8, 0, negative 6, 1, negative 4, 2, negative 2. We see a linear pattern, and so then we would draw the line passing through those points and arrow on either side. For y equals x squared minus 5, I'm going to use a few more ordered pairs. Especially once you see that it's what we call a nonlinear equation. Once you see that the variables are being raised to anything other than the first power, you want more ordered pairs. Generally want at least 5 ordered pairs for anything nonlinear. So let me set up a table of values again. And I'm going to use negative 2 through 2 as my inputs. So we would have negative 2 squared minus 5. That's 4 minus 5, which is negative 1. Negative 1 squared minus 5, which is 1 minus 5, is negative 4. 0 squared minus 5 is 0 minus 5, which is negative 5. 1 squared minus 5 is 1 minus 5 is negative 4. And for 2, we'd have 2 squared minus 5. That's 4 minus 5 is negative 1. So again, we have some ordered pairs here. Negative 2, negative 1. Negative 1, negative 4. 0, negative 5. 1, negative 4. And 2, negative 1. And so we see a pattern here, and if we wanted to, we could go further to the left or to the right to extend the pattern. In fact, I'm going to do that. Let me go a little bit further to the left and to the right. What if our next input, how about negative 3? If x was negative 3, we'd have negative 3 squared minus 4. That's 9 minus 4, which is 5. And if x is 3, we would have 3 squared minus 4. 9 minus 4 is again 5. So I also have negative 3, 5, and 3, 5. And so I see a pattern forming here, and this shape is actually called a parabola. And so we would have a shape that looks roughly like this.